Students, in the last class we have developed the constant R circles. Now in this class we are going to construct the constant reactance circles. So already you know the basic equation for this reactance circles is x is equal to 2kx by 1 minus kr whole square plus kx square. So try to do the cross multiplication here, then you can say 1 minus kr whole square plus kx square is equal to 2kx, and then 1 minus kr whole square plus kx square minus 2kx by x, because this x is in the left side, 2kx by x is equal to 0. Now I can write here 1 minus kr whole square plus kx minus 1 by x whole square, and if I write kx minus 1 by x whole square, it is having an extra term kx square plus 1 by x square. So I have to remove this minus 1 by x square is equal to 0, because a square plus b square minus 2ab. So now this can be written as 1 minus kr whole square plus kx minus 1 by x whole square is equal to 1 by x whole square. Now it is just like a equation of a circle. That is, the center is kr is equal to 1 and kx is equal to 1 by x. That means you can say here the center of the circle is 1 and 1 by x, and the radius of the circle is, you can say, radius is 1 by x. So if you are substituting different values of the reactance here, then you are going to get different types of circles, just like our constant R circles. But the only logic is here, this x may be positive reactance or negative reactance, but whereas the resistance is only always positive. So now if you see this table, just to save the time I am giving this table here. So it is x is nothing but a normalized reactance, and the radius is 1 by x, and the center is 1 comma 1 by x. So now this table is actually prepared for different values of the reactance here. So now you observe the values of this radius as well as the center for different values of the reactance. Now suppose, for example, if you take x is equal to 0, what is the radius? Radius is 1 by x, 1 by 0 is infinity. What is the center? 1 by 0 is infinity, 1 and 1 infinity. So exactly like this, try to substitute all the values, and here I am taking the x value plus or minus, because the reactance may be positive or negative. It is a capacitive reactance or inductive reactance. So what is the inductive reactance? J omega L. What is the capacitive reactance? Minus J by omega C. So it may be having two values here. So for the different values of the x, just substitute in the formula and try to calculate this. Suppose, for example, if you take the last one, plus or minus infinity. So if you take x is equal to infinity, radius is 1 by infinity 0, radius is 0, but the center is 1 by infinity means 0, 1 comma 0. So you try to prepare a table like this, and now try to implement this table in your Smith chart. And what is a Smith chart basically? Smith chart is nothing but a complex representation of your reflection coefficient. So reflection coefficient k is not a real number, it is an imaginary number. So it may be having both real part as well as imaginary part. So this is nothing but a circle here, just like a constant R circles, this is a circle now. So let us take the first value, x is equal to 0, and if x is equal to 0, radius is infinity and the center is 1 comma infinity. So what is the center here? It is 1. And what is it? Infinity. This is nothing but the infinity totally. So that's why this line is totally indicating your x is equal to 0. It may not be having plus and minus. So this entire horizontal line is nothing but this line, that is for x is equal to 0. Exactly, if you are taking plus or minus 1 by 2, so this is 0, and if you are moving in this direction, it is plus 1 by 2, and this is minus 1 by 2. So this is 0.5, it is minus 0.5. So what is its radius? radius is 2 units and the center is 1 comma plus or minus 2. So you can say that this is this. Now 1, always this is the 1, it is touching the always the point 1 here. Of course, the vertical distance may change, that is plus or minus 2 means, and this is 0.5. So now if you do it, the units is 2, and if you are taking like this here and it is touching this 1 point like this is plus. This is nothing but plus 1 by 2. Exactly, minus 1 by 2 means replica of this. That means on the negative axis. So you can say that this is nothing but your, this is. You can say this is, and actually you can draw like this. This is nothing but your minus 1 by 2. Exactly, if you are taking plus or minus 1 and its radius is 1, what is plus 1 plus or minus 1? That means what is the center? Center is here, it is 1, and it is at plus 1 and minus 1. 1 means this is, and 1 minus 1 means this one is. So you can say this is the circle of radius. What is the radius? Radius is 1, means it will go like this. This is the circle. And exactly, and this is also a circle. This is nothing but a circle. It is going like this. This is 1 unit. So these are nothing but the positive reactance circles, and these are nothing but the negative reactance circles. So exactly you can do this plus or minus 2. 2 means this one. So this may be like this. What is its radius? Its radius is nothing but 1 by 2. So 0.5 circle, small circle will come like this. And exactly this is also 2. And if you are taking this plus or minus 5, 1 by 5, its radius is very, very small. So that's why you can say this is the circle, and 0.5 means probably it may come like this, and this is nothing but point, it may be like this. So the last and final one is x may be plus infinity or minus infinity. You see, x may be plus or minus infinity. Its center is 1 comma 0, this is 1, and 0, this is the axis here. And what is its radius? So this is the point. This point is nothing but x is equal to plus or minus infinity. So friends, I am telling you, all these things are noted in this unit circle once again here. And upper one is nothing but the positive reactance, and the lower one is nothing but the negative reactance. So very simple. Your Smith chart is nothing but the representation of your impedance. That impedance may be Z is equal to, I can say, that is 50 plus J100. Okay. First normalize it. How to normalize? Take the characteristic impedance Z0 is equal to 100. For example, he has given here. Therefore, what is the normal impedance? This is nothing but ZR. Z small r is equal to 50 by 100 is 0.5 plus J1. J1. So what it indicates? It is having a resistance circle as well as a reactance circle, that too plus J. These plus values are always will be on the upper side. So this is called positive reactance, means you can say this is called inductive region. This is inductive. But whereas this one values, these values are nothing but negative reactance, it is called capacitive. This is capacitive. So this is the way of developing the constant reactance circles. I already told you, Smith chart is nothing but the combination of two orthogonal circles. They are nothing but constant R circles, constant X circles. Very simple. You got the basic equations are nothing but the circle equations, and substitute different values of R and X in those equations. You are going to get constant R circles and as well as constant X circles. So both are limited to this unit circle only. And whatever you are observing here, nothing but constant R circles, and you are also having the circles in the upper side, that is called positive reactance circles, and these are nothing but the negative reactance circles. Now the last and final trial is, try to superimpose this figure on this figure, that is nothing but your Smith chart. So how to superimpose? Just you try to take this figure and cut it and you paste it here. You are going to get like this. How you are going to get this? Positive reactance means upper side. You can say that these are the values. These are nothing but these positive reactance circles. You can say different circles. Exactly, lower side you are going to get negative reactance circles like this. These are the negative reactance circles. These are the negative reactance circles. So these circles and these circles are orthogonal always. Suppose for example, if I want to take that this is the 0.5 plus J1, I want to denote this impedance on this Smith chart. ZR is equal to 0.5 plus J1. What is that 0.5? 0.5 is nothing but the radius of the resistance circle. And J1, what is J1 here? This is nothing but the J1. Whatever it is touching is nothing but J1 here like this. So this is 0.5 and this J1 circle is here. Now this is the point of this ZR. So once you know how to represent a load on this Smith chart, you can do so many number of problems. First of all, before using this Smith chart, and let us understand how it is constructed. And how it is constructed, very simple. It is nothing but the intersection of two orthogonal circles, resistance circles as well as reactance circles. Now if you see this, this is the diagram of the complete Smith chart. So whatever it may be, whatever the problem it may be, and you take that problem now and try to do the normalization for this and identify that point on the Smith chart, and you are going to calculate all the parameters. Okay, so that's why normalized impedances will be shown in this Smith chart like this. So basically I can say Smith chart is meant for calculating all the transmission line parameters like reflection coefficient, standing wave ratio, input impedance of a transmission line, or otherwise for designing of a single step or a double step. And if you are having a practice on it, and within no time you can do all these types of the problems. So once you know that Smith chart is a combination of your resistance circle and reactance circle, and in the next class I would like to tell you the property of the Smith chart. Once you know the properties of the Smith chart, and then happily you can do the so many number of problems using the Smith chart. Of course, Smith chart is a old technique, but if you are having a practice, definitely within no time you are going to get the calculations. There is no need of calculators or computers. ఏం అవసరం లేదు, డైరెక్ట్గా చార్ట్ మీద కమాండ్ ఉంటే చూసి వెంటనే డిజైనింగ్ చెప్పేసేయచ్చు. సో ఐ హోప్ యూ అండర్స్టూడ్ హౌ టు కన్స్ట్రక్ట్ ద స్మిత్ చార్ట్. And particularly in this class, I told you Smith chart is nothing but superposition of these two circles, constant R circles, constant X circles. So this rounds one is nothing but the R circles, and upper one is nothing but a positive reactance circles and the negative reactance circles. Upper one is inductive, lower one is positive, and these are nothing but the resistances. Okay, I hope you understood this, and in the next class we are going to see the properties of the Smith chart. It means I would like to tell you how to utilize the Smith chart for the calculations. Okay, thank you.